equal to 1. Great. Now let's find the limit as n approaches infinity. So as n approaches infinity, this will be infinity, and this whole thing will just be 0. So you have a theta times by 0, which is indeterminate. So what we're going to have to use is L'Hopital's rule. But this isn't in a fraction form, so what we're going to do, we're going to force it into a fraction form. Now if we take the limit of both sides as n approaches infinity, we get that this is just infinity, and x approaches 0 from the positive side. So we now have this thing that we need to solve, and we can just apply L'Hopital's rule, and you have to know your derivatives really well for this. So we have this derivative differentiates to 1, and this differentiates to this big fraction over here. So now as x approaches 0, this is going to approach 0, which means that this whole thing is going to become 0. So we're left with the limit as x approaches 0 of theta, which is just equal to theta. So what we're left with is that z to the n is equal to 1 times by e to the I theta, which is just equal to e to the I theta, which is exactly what we were looking for. There we did it, QED.